Okay, good afternoon. Today we will continue discussing a very important topic related to our course. But before we do that, I would like to remind you all that the final exam is 40%. It's written exam. There will be no programming, like lab test 1 or 2 or 3. So it's mainly written, and it will be on April 12. Okay, that's Friday at 2 p.m. So please mark this in your agenda. Still, we don't have the room number. Room number is not assigned right now, but the date and the time is fixed. Okay, so please mark it to your calendars and make sure you are ready at that time. Okay, it's 40%. We're gonna discuss more about the final exam later on, but just today we're gonna announce the date and the time for the final exam. No, it will be, most likely we will have 2 parts. We say questions that you have to write and evaluate and do whatever we ask you to do in that, and there is part for multiple choice. But still, we don't go over there. We will give you more information about the final exam later on. Now, back to the previous lectures, we complete the collections, and we discussed the list, set, and map, and we saw examples about hash set, hash maps, and also array list. And we introduced the concept of inheritance last time, and we discussed some main ideas about the inheritance and how much the inheritance is useful for us. Today we will continue inheritance. Actually, for today lectures and maybe next lectures, we will stay on the inheritance. Inheritance is very important topics, and it's considered new for most of you. So that's why we try to make the slides comprehensive, include all the details information. So whenever you need to read the topics or understand the topic, you can refer to these slides and read more about it. Today we will look at the inheritance, but we will visit the construction and initialization, but now from inheritance point of view. So when we extend the class and how the constructor is working, how the effect of inheritance, we use the keyword extend on the creation of the object, how this keyword gonna affect the hierarchy, and how this keyword will affect the initialization and constructors of the objects. And we will introduce the topics of overriding, okay? Overriding the method, having the method defined on the superclass, then you extend the superclass to create a subclass. You decide to override the behavior of the method. And also we will revisit the access modifiers. But now we will gonna view this access modifier from the point of view of inheritance, and how the inheritance is gonna affect these access modifiers. When we say private, what do we mean by private from the point of view of inheritance, or protected, or public? So we discussed last time and introduced the inheritance. If you look at the Moodle and there is a note, the textbook, or you have chapter number 6, discuss all the inheritance. I encourage all of you to go to the Moodle, download this PDF file, and look at the chapter number 6. Now, we already go over these 4 main methods to construct something, to create something on the Java inheritance, our topic today. Java abstract, we're going to try to introduce it today. Java interface, we already introduced this topic in the previous lectures, and we saw that the interface is very useful to define some kind of common behavior between the object, and any object decide to implement this interface should implement all the method inside that interface. Java polymorphisms, this is another way related to the inheritance, how you can create a more generic way to call them subclass and treat it as superclass. We will see some example later on. I don't think we will be able to go over the polymorphism today, but maybe next lecture we will discuss polymorphisms. Inheritance is in very simple word, is you already create an object that is represent a collection of fields and methods. So the fields as attributes of that object, method as a behavior of that object. Now you try to extend that object. You create it, you want to extend it. You don't need to duplicate the code again. So you extend the existing objects. So you create a special version of the existing objects, okay? So that will allow you to reuse whatever you already wrote for the previous objects. You reuse the existing object by extending it to create a special version of the objects. Now, at the end of the result, you will have a very specific object, the object that you extended. So we call it subclass, derived class, and child class. These are the most three famous words. You will find it on the literature if you go read online or read some reference book. Some of them, they adapt one of these and stay with it until the end of the topic. So when you have the extend the original object, you call it superclass, the original object, or parent class, or base class. So you have these three keywords, and we're going to use it in this lectures. We're going to change between them and switch, but all of them mean the same thing. So subclass is the child class or derived class. So superclass is the parent class, the same thing. If we use base class, it's the same as superclass. So all these keywords use the same thing. Superclass, base class, or parent class, all of them refer to the original class. Then once you have the original class, you extend it to create subclass from superclass, or you have the parent class, you extend it to create a child class, or if you have base class, you extend it by creating a derived class. Okay? So the superclass reference, if you put the superclass reference on the left side, you can use it to refer to an object from the superclass, or you can use it to refer to an object from subclass. This is an example we discussed last time. We say that we have a company. This company maintains name, address, phone numbers, employee numbers, and hourly pay rates for each employee. So these are the features or the fields that are already maintained for each employee. A few of those employees, they are managers. And once we classify this employee as a manager, the hourly rate is very high compared to the employee. And also, each manager has a list of duty need to maintain. Now, when I say each manager has a list of duty, that means employee doesn't have this kind of field. Okay? Now, each manager has a list of employees to work with. So we have some fields that are related to the manager and some fields that are related to the employee. Now, we discussed this last time. We said that one of the possible Java hierarchies, okay, you have a base class as a person or a super class as a person where you maintain some fields. Here we have a person, we maintain three fields. We have names, address, and the phone that are part of the person attributes or person fields, okay? Then we extend the person to create a new object. So we have the existing object person, we extend it to create an employee. But now we don't need to add name and address and the phone number for the employee because we are extending the person. So these are already exist on the employee. We just add the employee number and hourly rate. Now, the manager are employee. So that's why we extend the employee more further to create the managers. Now, the manager, they have the name and the address and the phone numbers, but also they have two special fields. They are duties and subordinators. So they are coordinate between list of employee. As you can see, we define those list of employee as an array of type employees. So now you can see here the manager inherit 3 from the person, 3 fields from the person, or you can say 3 attributes from the persons, and 2 attributes from the employee, and that's total make them 7 attributes in addition to the duties and subordinates. So all of this, you see the time and the saving of the code just simply by defining these fields. We don't need to define names and address and the phone number for the employee because we are extending the person. We don't need to define name and address and phone number, employee number, and hourly pay for the managers because we are extending the employee. Now, the employee is a subclass for the person. Person is a superclass for the employee. Okay? And the manager is a subclass for the employee. Employee is a superclass for the managers. This is an example where you have everything for a company has hourly employee and they have a salary employee. Hourly employee they divide between part-time and full-time, and a salary employee divided by technical staff or executive staff. So by giving this description to you, you will end up with a unique Java class hierarchy, that you have an employee, you have hourly rate and salary, and then you have full-time and part-time and technical and executive staff under the salary employee. Sometimes the requirement that you have end up with a unique Java hierarchy. But in most of the case, if you are trying to build Java application, you have to go and collect some kind of information, okay, and then analyze this information to end up with some kind of Java hierarchy. And you might change this hierarchy while you are collecting this information until you finalize it, you get approved, then you go to the phase of implementation. Now, you can see this example. We discussed it last time quickly, but now we go over it in details. You are decide to go to the bank and build an application for the bank. You went the first visit. They told you we have a bank account and we always maintain 3 common attributes for any bank account that we need to create in our bank. We have owner name and account numbers and the balance. Whenever we decide to open an account, we need these 3 mandatories. These 3, they should be available for us. Now, also, any account, by default, we should have the behavior, or when we call a behavior, that means methods. Behavior, method, because we can implement this behavior by creating a method. So we have a behavior of deposit, okay? That means put something on the account, put some amount on your account after you open it, and then withdraw. That will take some amount of money from your bank account. So we have an object as a top of the hierarchy, and we build what we call a bank account. That is our first visit to the bank. And by collecting these very simple information, we end up with this very basic hierarchy, and we end up with this class. So all what you need is one object. So I create a class called bank account. I have a string as a field, owners, and I have integer bank account numbers, and we have a balance. We have a default constructor, as you can see here. The default constructors is initialize the owner by empty strings, and also initialize the account number by 0, and also we initialize the balance by 0. This is what we call a default constructors. If we didn't provide this in our class, the Java will put some default constructor for us, but we don't need to do that. We try to make it more systematic. That's why we put the default constructor, no argument constructor. So if this no argument constructor is missing, Java will put the default one, inherited from objects. Now, we have one customized constructors that we receive the owner name, and we initialize the owner string by giving the owner name that we receive as an input, but still we have the account numbers and the balance as 0, 0. We have the deposit method to implement the behavior of the deposit. Whatever amount we have, we add it to the deposit, and we have withdraw. We're going to ask if the money that you're going to take from the account as a conditions is greater than the balance or less than the balance. If it's less than the balance, then we can take it out. If otherwise, we do nothing. Okay? There's no exception is raised or nothing to notify that this withdraw operation is not succeed. Okay? The only check here, we ask if the balance is greater than the amount, we're going to do it. Otherwise, we do nothing. So this is very simple class. Only one visit, we are able to create this class. Any question? No, we use exceptions in inheritance. I'm saying I just implement this without any raising any exception. Okay? Any other question? Now, you go to the bank again, the second visit. They told you the bank, we are offering two types of account, saving account, non-saving account. And if you decide to have a saving account, you cannot take the money out from the saving account. To take the money out from the saving account, you have to close it. But you can take money from non-saving account. So, second visit, extra information, we need to change something to our applications. We started our application by creating only a very simple class called bank account. Now, no, we have more information that will be translated to the Java hierarchy. We're going to change the Java hierarchy right now. So someone say, okay, I don't need to change anything. Only thing that I need is saving account. I'm going to do this simple line, and I will say my job is done. See, this is very simple line. I say public class saving account extends account, bank account, and empty. There's nothing written inside it. What do you think will we have here? Bank account will be the superclass. How many attributes inside the superclass? How many fields? We have the name, bank numbers, and the balance. All these fields will be inherited and be part of saving account. And inside the bank account, we have constructors, and also we have two methods. Let us see. So, job is done. This is a virtually empty class. We are extending the bank account by creating a saving account, and this saving account will have three attributes and will have the deposit and withdrawal methods. So, one of you decided to use this class, saving account as equal new saving account. So here we have the type is saving account, okay, reference type, and we create an object of type saving account. Can we do this? Can we do this? Why not? Yes, we can do it. There's nothing say no. We're going to call the default constructor, yes? Oh, default constructor inside saving account. Where is it? It's empty. There's nothing inside it. See? There's just an empty Java. Where is the constructors? You're going to take it from... So you're saying we cannot do this because we need the constructors. And you are saying, yes, we can do this. Nothing prevent us from doing this because we are going to go and have the constructor from objects, from bank account. Yes, we have constructor from the bank account. We're going to use it. But remember this and keep it in your mind. Constructors, you cannot inherit the constructors. This is very, very important. We cannot inherit the constructors. So let us see how this happens. Until now, we can do it because we're going to go to the object. And this is the answer. But let us see more discussion because if you go back after 3 days to read the slide, you got confused. You will not forget what happened. I put everything on the slide. So you print the balance. What do you think the output? We just create the account. 0. Now, you add some amount to the bank. Can we do this? Yes, we can do because we inherit the deposit method from the bank account. The bank account implement the deposit method, and we just simply by putting this public class saving account extend bank account, we have this behavior. What's the output? 120. Now we're going to take the money out. Can we do this? Yes, we can do because we inherit the behavior from the bank account. Bank account going to ask if 20 is less than 120. That's right. We're going to take the amount out and the balance will be 100. This is what we got. Now let us see more discussion. Does the saving account inherit two constructors from the bank account? The answer is no. We don't have the inheritance. Inheritance for the constructor is not valid. We not inherit the constructors. Then what happened? We got the default constructor, the free of charge constructor. You remember when we discussed creating the object, if we didn't provide any constructors, Java will insert the free charge constructor, which is the default constructors, and no argument constructors. That's what happened. We do nothing related to the inheritance here. We not inherit the constructors. We got the free charge constructors. Let us don't say F, because all this will be later on in the slides. Okay, let us go in step by step. So we have the free charge constructor that we got it from the Java. Now, to make sure, can we do this? We cannot do this because the constructor is not available, and we will have the Java compiler. Okay, good. This constructor is not available. That's why we don't be able to make saving account by giving the argument, which is the string, the name of the owner of the bank account. Okay. So that's exactly this slide explained how the initialization of the bank account. We got the free charge constructor, which is exactly like this. Public saving account. If you didn't provide the constructor with no argument, this is the constructor will be inserted automatically by the Java. It's not will be visible for you, but this is what Java will use this one, okay, to call. And you can see here super. What is this keyword super means? This super mean refer to the super class, okay? The super class. In this case, the super class is what? The bank account, okay? And that is where we can construct the saving account, okay, using the constructor of the bank account, okay? So this is what the default constructor we got from the Java, okay? And you can see here, by inserting super, we now not referring to the super class, the immediate super class. What is the immediate super class in this case? Bank account. We're going to look inside the bank account. Do we have no argument constructor there? Yes. If we don't have, we're going to go back to the object. Okay? You have a question over there? If the bank account does not have no argument constructors, in this case, it has no argument. It has argument and non-argument. It has two constructors. So what do you question? This is no argument. We're going to call no argument constructors from the bank account. It will go to the bank account, nothing there. That is your question. There's no argument constructor inside the bank account. Then it will go to the object. Still this work. Okay? Yes. We have no argument constructor inside the bank account. Yes. Yes, it will look for the same constructor with the same list of arguments and the type. The signature would be, yes. No. This always point to the object that is being constructed. Now we are constructing the saving account object. So whenever you are using this, you are pointing to the saving account. If you would like to go to the bank account, which is the super class, you have to use super. Super is used to refer to the methods and attributes inside the super class. You mean you have a class that extends the saving account, and saving account extend the bank account. Super will look for the immediate super class. What is the immediate super class? We're going to look inside it. If we couldn't find it, We're going to look inside the super of the superclass until we reach the object. It's a constructor. By doing like this, we call the constructor of the superclass, the immediate superclass. Okay? We're going to see some examples later on about your case. So, someone try now to add argument constructors. And this is most of your questions about this one. So, we have the saving account extend the bank account. And we create a constructor called saving account that will construct saving account for us, and we give an argument to the name. Inside it, we call super, and we give a name. In this case, we're going to go back to the bank account, and we call the constructor with the argument of string. So we're going to initialize the saving account by the name of the owner. We're not inheriting. We are calling the constructor. Remember this. This is very important. We're not inheriting the constructors. We are calling the constructors. Okay? We're calling the constructor from the superclass because the constructor of the subclass, what's the main objective of the constructors? Is to create the object and initialize the fields, okay, on appropriate state. So when you create the object, you need the field to have valid values, okay? So the constructor is responsible to do this. Whenever you are trying to construct saving account, remember, saving account inherits some fields from the bank account. So you need to initialize these fields in appropriate way to be able to have an extend object, which is the saving account. That's why we are calling the constructor of the superclass. Now, if we create a saving account and we give the name for the, it will work. Why? Because now we are calling the super constructor. And remember, if you are calling the super constructor, you have to provide with the right signature. If the right signature does not exist in the superclass, it will look for the upper class. Then if it does exist in the object, it will give you what? An error. So this is the advantage of using the inheritance for the constructor to call the constructor of the superclass. You have, if you, without using the inheritance, you have to create a saving account, no argument constructors, and you have to create a saving account with one argument, which is the owner name, and you have to initialize this. But with inheritance, you just simply using the public saving account, you call the super with an empty string, and public saving account, you give the owner name, and you just call the super. So we are able to call the constructor from the superclass. So saving account can call the constructor from the bank account, cannot call the object constructors. The object is immediately superclass. I mean, this is very important hint. Saving account cannot call the object constructors, okay? But it can call, this is back to your questions. We cannot call the superclass by using this, okay? You remember, if you want to call the constructor, you create the object, you can use this, and you give the argument, it will call the constructor of the object that is being constructed now. So because always this is pointing to the object of you are trying to construct. So that is why we are saying that we cannot call the object of the superclass by using this. We can use the super to call the object. Some fact about the constructor of the subclass. These are the fact we already discussed, but I put it here to list it for the purpose of, you go back to the slide. So for the purpose of constructor is to set the value of the field of this object. So how the constructor, this is very important questions, how the constructor can set the field that belong to the superclass if these fields are defined as a private. No one can touch them. Okay? We use the constructor. Constructor always can set these fields. So the first line of the body of every constructor must be the call of another constructor, which is the constructor from the superclass. if you don't do this, Java will insert this, okay, for you by calling the default constructors, which is the super and with empty argument, even if you don't do that. So calling to another constructor can only be occurred at the first line. You cannot put it at the second line or third line. You have to construct the superclass object before you start constructing the object of the subclass. So the superclass constructor must be called during the construction of the derived class. So you can call this, use this to invoke the subclass constructors, and you have to use super to invoke the superclass constructors. The amount of code that you need to write is reduced because of the inheritance. Now, we have the saving account that inherit the bank account, and remember, still we can take money from the saving account, but we didn't complete the job. We're supposed to put the money on the saving account. You can deposit inside the saving account, but you cannot take money from the saving account. Now, by just simply inherit the bank account, we got two behavior. We got two methods. Deposit, that's what we like, but we got also withdraw we don't like. So how we can do? We can prevent or disable the behavior of withdraw. How we can do this? The most common way is to rewrite withdraw method inside the saving account that actually do nothing. This is what we call overriding. Just simply rewrite the same signature of the method, public void withdraw, and float the amount and empty body. This will do nothing. So even if now you create an object of saving account and you call a method withdraw, it will look inside the object of saving account. Do we have this method? Yes. Then we're going to execute it. What is inside it? Nothing. Okay? So this bank account, right now, we have two constructors inside saving account, one with the argument, one without argument, and we have only one method withdraw, which is overriding the method from the bank account. Still now, if we call the saving account deposit, we're going to look inside the saving account. We didn't find it. So we're going to go back to the immediate super, which is the bank account, and we will find the deposit there, and we're going to execute it. So we define the saving account. We try to print the parents. What do you think the output now? Based on this class. Given this class for the saving account, the class on this slide. So if we try to create an object of saving account and print the balance, what do you think the output? 0. If we deposit an amount, 120, and look here, s.deposit, we're going to look inside the class of saving account. Do we have a method deposit? We don't have. So the compiler will look at the super class. Yes, we have a deposit when we execute it. If there is no deposit, we're going to go back again to the object. There is no deposit, we're going to have the error. Okay? But now we have the deposit inside the bank account. We're going to execute it. The balance will be 120. Now, if we need to withdraw $20, what do you think the output? 120, because we have method already overridden inside the saving account. We're going to call it, which is do nothing. Okay? What actually happened? I listed here in this slide. We're going to look at the withdraw method inside the saving account, which is actually overriding the method of the bank account. And we replaced the inherited behavior. Okay? By overriding this method, we erase the inherited behavior. We prevent from withdrawing. Sometimes we need to extend the behavior. But in this case, we prevent the behavior by overriding and just implement an empty method. So by doing this, actually we prevent or disable withdraw method. Okay? But again, I told you sometimes you need to extend the behavior. Okay? So the constructor and initialization, some general information. When the subclass object is created, its constructor is called, and its responsibility for the subclass constructor to invoke the appropriate superclass constructors. Okay? That all the instance variable defined inside the superclass should be initialized in the appropriate way. Now, the call to the base class. Base class is the same as superclass. Constructors can never be using the base class name. We cannot call the constructor by using bank account. okay, we have to use super keyword. Okay, inside the saving constructors, saving account constructors, we cannot call the bank account constructor by using the name of the class bank account. We can use only super, okay, to call the super class constructors. So calling using super class, similar to this, it must be the first line of your code. You cannot call the constructor on the second line or the third line. You have to construct the superclass object before you construct the object of the subclass. If you don't do this, if you decide to create a constructor for the subclass and you didn't include the super keyword inside the first line, the Java will automatically do it for you and will put super with no argument at the first line. Now, back to the bank account example. You visit the bank again, the second time or third time, they will tell you, okay, now we need to encourage the deposit. Whenever you deposit $100, we're going to give you $50 free. Okay? So if you deposit 354.23, that will be 355.73. So we give you 0.5 for each $100. Okay? How we can do this? So still we have the saving account, but now the deposit behavior is changing. So we can extend the deposit behavior of the bank account. Okay? You see, the withdraw, we prevent it, we disable it, but now the deposit, we need to extend it because its behavior has changed. So someone decided to do this. Public void deposit, give me the amount, and I implement this method inside the saving account. I will take the amount, put it inside the balance, and then I calculated how many $100 inside your account, and I will add the rest to the balance. That is completely overriding the deposit account inside saving account. Someone say, no, I want to use the inheritance. I learn what does the inheritance mean, save the amount of code, use the amount of code. I don't need to repeat all the job. So I just call super dot deposit, and I will deposit the amount. Then later on, I will add the money. Someone say this without inheritance and this with inheritance. But again, someone decide, I will do better than this job. I will reduce the amount of code by doing this. I will calculate how many $100 you have in your account money. Then I will do super dot deposit. Look here, super dot deposit, I'm calling a method inside the super class. I can call it at the end of the body of the method, but whenever I do super to constructor should be the first line. Okay? Here it doesn't matter at which line inside the body of the deposit. So I calculate the how many $100 in your amount, and then I do one call for the super dot deposit. Someone say, I do better. One line is enough. So as you can see, as long we are going in this class, we have discussed the implementations. The implementation, there is no unique implementation. I just show you 4 types of implementation. Which one will deserve, if we're going to give 4 grade for this, which one will deserve 4 out of 4? No, not every one of them. This will maybe receive 2 out of 4, the first one, without using inheritance. We have to use what we learn in this class. We have to use the inheritance concept. Maybe the second one will use 3, but these 2 most likely they have 4 out of 4. We have to use the concept of inheritance. And also, we have to reduce the amount of code. Okay? If you're going to use without inheritance, then what's the impact of learning there is a Java inheritance in the type of the style of your programming? So you should reduce the amount of code, and we should use the code that exists inside the super class. So in the implementation for the lab 4 or inside the lab test 3, I encourage all of you to look at such kind of implementation where you are using the super class to call the methods, not re-implement everything from scratch without inheritance. Okay? We have to use inheritance. Okay? So the overriding is very powerful tools that can save the coding time. Okay? Very powerful tools. Now, you visit the bank again. They change every time. Every time you visit, you collect more information. Okay? So they decide to say, look, we will have one thing is called power saving. But now we allow you to take the money from the saving account, but we're going to charge you $1.25 for a service fees. Okay? There is a service fee whenever you are trying to take money from the saving account. Okay? Now we come to the very interesting ideas. But still, we have the same concept of deposits. We still have, if whenever you deposit $100, we're going to give you half 50 cents extra. Okay? So this is the hierarchy that we have. Yes? We started with the bank account and object. We extend the bank account to the saving account. Where do you think we can put the power saving account? This is a live, in this class, you will have a live discussions that you can face whenever you are trying to create an application for the Java. Okay? You collect informations, you change, you revise your Java hierarchy, you change it, you change the way that attribute and how you implement the method. That is what you're going to face on the real time or real life. Okay? Where do you think we can put it? Below the saving account. Someone say, okay, we will have the deposit the same as the saving account, but we have withdraw from the bank account. And withdraw has some special behavior. So the power saving account is subclass from the saving account, and we will inherit deposit. That's good. I'm not going to do anything for the deposit, but I'm going to re-implement the withdraw. Now I'm not going to do nothing. I'm going to change it. Okay? So that is the one of the possibility of doing this. Doing the power saving account, going through the extending the saving account. So the hierarchy will be looking like this. And I have the power saving constructors and power saving no argument constructors. And now only just I'm going to override one method, which is withdraw. I'm going to give the amount. If the balance is greater than the amount plus $1.25, because now there is a fee for this service, I will deduct it. Otherwise, I will do nothing. Okay? Any question? Good. So now let us test our knowledge. We create the power saving account. We try to print the balance at the first line. What do you think the output? 0. The second? No, we are depositing now. No, not 320. Yes, we have inherited the behavior of the saving, because whenever you deposit $100, we're going to give you 50 cents extra. Okay? We're going to take now $20 off. Can we do this with the power saving account? Yes, we can do. So we're going to call it, and we're going to get $300. Okay? Test your knowledge. Someone say, okay, why I'm going to use inheritance now? I'm not going to re-implement. Look at the previous here, the previous slide. Did I use any inheritance inside withdraw? Did I use any inheritance? Did I call any super methods? I just override everything. Someone decide, okay, I will stay the same hierarchy. I will extend the saving account. But this time, I will do this. I will say the power saving account, extend the saving account. But when withdraw, I will call super dot withdraw, and I will give the amount plus 125. So that's what I'm doing. I'm going to just, why I should ask, so the super class should take care of it, yes? It's okay. This version is not working. Why? Any suggestions? Yes? That's right. Saving account has a method called withdraw, and inside it do nothing. So we're not going to take the money out. We have to be careful whenever we are using inheritance. As super, we call the super method. That's right. So super is referring to the saving account. Inside the saving account, we have withdraw method. That is actually do nothing. Okay. Someone say, okay, let me just revise the hierarchy. I will have what I call a saving account, but I will have super saving account and power saving account. I will go to the bank and propose this idea to them. Okay, we will still have the bank account, and then we have a saving account, but we created two things now. We have a super saving account and power saving account. Okay, so the saving account that extends the bank account will have the same thing, but as you can see, there is no deposit inside it. Okay, I mean, there is no withdrawal, just only deposits. Okay, and inside the saving account, we have the deposit behavior that encourage the deposit the amount. Whenever you deposit $100, we're going to give you 50 cents. Okay, and then we have a super saving account that actually extends the saving account, but in this super saving account, you cannot take the money out. You cannot take the money out. You can deposit with some encouragement intensive. We give you 50 cents for each 100, but whenever you decide to withdraw, we're going to do nothing. Okay? But again, we have extended the saving account, but now to create what we call a power saving account that allow you to have the same deposit behavior, but also allow you to take the money out with some service fees. So he revised the hierarchy in this slide, and we propose it to the bank that's how we can do this. And you can see here, we call super.withdraw, and we give the amount. In this case, we're going to call super. What is the super here? For the power saving account is saving account. Inside the saving account, do we have withdrawal? No. Where are we going to go? To the bank account. You see, whenever you are calling the method, you go into the immediate parent. Or actually, you go to the, in this case, we are directly asked for the super class. Super.withdraw. We're going to go to the super class, saving account. Do we have a withdrawal? No. So we go to the super, which is the bank account. We find it there. If we didn't find it, we're going to have an exception at that time. The method does not exist because something does not exist. Okay? Any question? So that is what I said. Remember, whenever you are using this .my method, Java will look first to see if you have such kind of method inside your class. If there's no method, Java will look up on the hierarchy, never down, up on the hierarchy. Look up on the hierarchy to see if this method exists on the super class until we reach the object, which is the parent or the super class of all the classes that we create inside our Java application. Okay, most of the time students get confused, and every time I ask these questions on the lab test, I have some answers, wrong answers. It's confusing here between overloading and overriding. Okay, and overloading is you are talking about the same class. If you want, you can link them like this. Overloading, you are talking about the same class. You will try to give the same name of the method, but with different signatures. So the signature is different. You are trying to do the same behavior with different set of data. Okay, because the signature is different. Now, overloading, no. We are talking about dealing with two methods, one on the parent, one on the child. Okay, they have the same signatures. Okay, the same name, the same list of arguments, the same data. So this method exists on the superclass, exists on the subclass. They do the same behavior with the same data. Okay, or they don't do the same behavior because we override them. Okay, so they change the behavior with the same data. Overloading defines similar operation with different type of data, as we discussed. Overloading is defined similar operation in different way. Okay, for different object types. Okay, that's why we're overriding. We have object type of bank account and we have object type of saving account. This withdraw do nothing, but inside the bank account withdraw do something. We'll take the money. Yes. Not overriding, not overloading, because they have different signatures. Whenever you say different signature, different name. So let's say you define a method inside the bank account called deposit, and then you define inside the saving account called deposit 3. Different name, okay? That's name. The name is deposit. This is deposit 3. This is not overloading or overriding. This is totally different thing. You define totally different methods. One in the parent class, one in the subclass, totally different methods. This is not overloading, not overriding, none of the above. Okay? The only thing here is talking about if we have the same signature on the same class, same signature in the same class is not allowed. Yes? Different signature, but the same name on the same class, that's overloading. The same signature, but two different classes that are inherited using extend, that's overriding. Okay? Good? But if you have two independent class and they have the same signatures, two independent, there's no relation between them, you not call it even overloading or overriding, because they are two independent objects. If they have subclass and superclass and they are linked using extend keyword, and you will have the same method inside superclass, the same method inside the subclass with the same signatures, that's you call it overriding. Okay. Yes, we have to put annotation at overriding. That to indicate for the reader. It's okay for this examples, okay? Yeah. Now, let us visit now the access modifier, private, protected, and public fields. And from the point of view of the inheritance. I know the private from the previous lectures, that if I define a field as a private, I will not allow the client to access these fields. I can allow the client to access the private fields by defining get method or set method, yes? And this get method, set method will be a public method. Now, public fields allow the client to access this field immediately, okay? What about the protected? It's a new thing, okay? Let us see. So the private, no direct access to the client, no direct access to the subclass. So if you have fields inside your superclass and these fields are actually private, subclass cannot access them. As we mentioned, we use the constructors of the superclass to initialize these fields because we cannot access them. Public, direct access to the client, direct access to the superclass, subclass. Now, the protected has like between. If you have a protected field, there is no direct access to the client, which is similar to the private. And if you have a protected field, you will have access by subclass. The subclass can access this protected field inside the superclass. It's similar to the public. So the protected is give you the mixed behavior. It allows you to let the superclass open for the subclass, but superclass is still closed for the client. Okay? Any question about this? Yes. Yes, not you protected. You will inherit the field. No. Inheritance you will inherit the private fields. There's no problem. The fields, whenever you extend the class, you inherit the private and everything, but actually you cannot access them directly. Okay? That's why we have to use super and give the constructor to initialize them. Okay? Good? But the one here is called access modifier. Access modifier, okay, is not to limit the inheritance. Say if I define a field as a private, I cannot inherit them. No, I cannot access them. Okay? Here is the example. This is an example. I want you to look at it. We have a person and we define actually everything is private. We have the person, we have 3 fields. All these fields are private. Now if I have employee extend the person, employee actually has 5 fields. Has the name, address, and the phone number. But employee cannot directly access these fields inside the person, but is inherit them. Okay? We have the customers. Customer inherit the person. Okay? by adding some item to purchase histories, okay? And the manager extend the employee. I think by looking to this, you can visualize the hierarchy. We have the person as a root that give us employee as a derived class or a child class. We have a customer as a child class. And from the employee also, we extended to have the managers. Now the manager, how many attributes inside the manager? How many fields inside the managers? If I need to construct an object from the manager, I should initialize how many fields? 7 fields. Name, address, phone numbers, employee number, hourly pay, and the duties and subordinates. Okay? We inherit them, but now we cannot access them directly. Let us see. Okay? All the fields are defined or declared as private. So here the managers, we say we calculate the seniorities of the managers if the manager has the employee number less than 100 or has 5 employee work with that managers. Okay? We say that the manager has some kind of seniority. So you look at the manager class, you say this manager has a seniority. If his employee number less than 100, that means he is the first people are hired by this company, or this manager coordinates, okay, and they have more than 5 employee work with them. Okay? So how we can do this to implement this kind of seniority? Has seniority, Boolean gonna retain true or false. Is this manager has a seniority? And someone say, I will put it in one line. I will save the code. So I will put retain. I inherit the employee numbers from the employee. So if the employee number less than 100 and the subordinate dot length, the length of that array is greater than 5, I will return true. Is this code valid? Based on our previous discussion on the previous slide, all the fields are declared or defined as a private. So this code is written inside the manager class, has seniority. You're going to call it manager object dot seniority, dot has seniority. Is this code is valid? Manager can access the employee numbers. Employee number is defined inside the employee and is defined inside the employee as a private. So the managers cannot access the employee numbers. Okay? You will not compile this code because the employee number is actually declared as a private inside the employee. You inherit it, but you cannot access it. Okay? You cannot access that. How we can solve this one? You can access subordinate. There's no problem because this is a field actually is defined inside the manager. We can access it even using this dot. Okay? But we cannot access the employee number because it's part of the employee class and it's declared as a private. We cannot access this directly. To solve this problem, we have 2 solutions. The first solution is to define public get employee numbers. We define this method inside the employee that will retain the employee number for us. So we have public get employee, get retain integers. We're going to retain employee number. Now, this public get employee number is open and accessible by the client and also is accessible by subclasses. Okay? And manager is one of the subclasses. Then we can revise our code inside the manager class and we can say get employee numbers, and this will retain the employee number. In this way, we can access the private field. Now, another way is define it as a protected, not as a private. So when define it as a protected, the client cannot access it directly, but the subclass can access this field directly. So we define as a protected, so all the fields inside the employee, we define them as a protected, so the manager can access them directly because the manager extends the employee. So this is 2 solutions to access the private fields. Okay? 2 solutions to access the private fields. Now, this is very important examples. Okay? To measure if we understand the access modifier with the relation of this access modifier with the inheritance. As you can see, the hierarchy is the person as a superclass for the employee, and also the person is a superclass for the customers, but managers actually extend the employee. And we have this method defined inside the employee. And what is this method? Get employee numbers, get phone number as a public, change the password as a private method, and as a protected method, get the job completed. Okay, that will retain the array list of a string of the list of the job that the employee is completing. And this method is defined as protected. So the one without access modifier, what is the default access modifier for it? Private. It will be package access modifiers, which is actually inside the package. Inside the package. Most likely it's public. Okay? We will see. Now the manager extend the employee, and the manager try to print this dot get employee numbers. As you can see, the manager just extend the employee, and using this that means is pointing to the object of managers. I want to get employee number. I'm going to look inside the class of the manager. Do I have a method called get employee number? No. Then I should look in superclass. Now, just give me which one of these will be pass. Which one will give you code error, compilation error? Is the first one will be okay? The first one, look at this one. Keep this in your mind. Get employee number defined as without access modifiers. The get phone public, change password private, and job completed is protected. Which one will give me check? Which one will give me an error? The change one will give you error, and the rest is okay. If it's okay, it's okay. This will give you a compilation error actually. It will not allow you to compile, not runtime. Okay, because the change password is private. We cannot access them. Now you can see here we're calling this dot, and we look inside our object. In this case is the managers. We could not find get employee numbers. We look inside the immediate superclass. We find it. We execute it. We can access it. Okay. Okay. The same thing, but now I don't use this dot. I called some method, and I pass an employee object. I create an employee, and I pass it to this method as an argument, and then I use employee dot get employee numbers, get phone, employee dot change password, employee dot job completed. Which one of these will pass? Which one will fail? The first two, and why? Yes? Okay. Any other suggestions? Always work? So the first one will work. We are accessing using employee. Remember, we are not using this. And this is very important. Java knows what is inherited, what is not inherited. We're going to come to this topic later on. You create an object of employee. So you have object of employee now. Okay? When you create an object, think always about putting this object inside a sphere. Okay? And you can access this object from a certain doors. Okay? Now, if you define this door as public, that means anyone can enter this door, or anyone can exit from this door. If you define this private, that means you have some kind of sort key to access this, or nobody can access it. Protected, only for your child can go inside this object and access these. So now you are the object, you are the employee, and you would like to access your method, employee dot, inside, but this access inside the customers. Look inside the customers. We are doing inside the customers. Okay? So the customer is trying to access the employee. what is the relation between the customer and the employee? They have the same parent. That's the only relation, okay? So the employee will go, get phone number will go, private will not go, and protected will not go. Why? Because there's no relation between the customers and the employee. They are not subclass from each other. Protected only open door for the child, okay? Any question? It will be accessed by subclass. Yes. Protected, you cannot access it by client. Okay. Now, the change the access modifiers. If you have a private method inside your subclass, you have a superclass, and there's one method is defined as a private. You decide to override this method inside the subclass by saying public void do something. That's okay. That's okay. The superclass method was private. Now you decide to override it and make it public inside your subclass. That's okay, no problem. The opposite is not valid. If you have a public method inside the superclass, public void do something, you cannot restrict the access inside the subclass. You cannot make it private inside the subclass, okay? So the access modifier cannot be restricted, okay? It can be more generalized inside the subclass. So if you have a private inside your superclass, you can make it public inside your subclass. But if you have it public inside the superclass, you cannot make it private in your subclass. Do you think protected come lower than private, or the private is the most strange one? Private is more strange one. So public can make it protected, okay? Public, you cannot make it protected, sorry. You got confused here. Okay. So another thing about, we discussed the final. We say the final with the object. We can make a final constant, okay? Okay, most of the time we define final for the variable to define constant. But what about if we are using final with the method? If we are using final with the method, we are saying we cannot override this method. We write it on the superclass, and if you extend this superclass inside the subclass, we cannot override this method, this final method. Final method, that means all the child should have the same method. They cannot override it, okay? So we cannot override the final method, okay? Now, we can restrict the access, okay, of the class, but we have to make sure about the default and the public access of the class. This case, we have public class manager. That means is accessible for the client. Here is the class employee. We don't provide the public or private for this class. That means this class is package or a folder accessible. That's what we have always to be careful. If you design an application, you have to be careful about the package access. Some class can live inside the same folder. They can access some information. So we have to be always write our application inside the packages. If you decide to write it without using the packages, you have to be careful about what we call a default access for all the class that within the folders. We're going to come to the example to show you exactly how much dangerous this issue. So if we have final with the classes, this class cannot be extended. We cannot create subclass from this class. If we are using final class managers, we cannot extend this managers. So no one can extend these managers. And most of the Java classes like ArrayList, hash maps, hash sets are defined as a final classes for security purposes. No one can change the behavior of the ArrayList or hash map. They are all defined as final. So the final modifier, if we are using it with the method, we cannot override this method. If we are using it with the class, we cannot extend this class to create a subclass. This, I find it in the, from one of the reference, explain actually what happened for the default access. If you have some classes that are exist in the same folder, but there's no relation between this class and the class that you are working with. Here example, we have a class A, class B, class C, D, and E. And each arrow here represent the extend behavior. So class C extend A, and class D extend A. But you can see here, A, B, and C, they are on the same package. D extend A, but live in different package, and E is living also independent from different package. And the diagram, when we have access, we mean by that we can direct access this field with the name, by the name. And the instances are replaced by the method with the same access rule will be applied. So look here, you define V1, V2, V3, V4. V1 is a public, so the V1 can be accessed by the C, because C is the subclass of A, and V1 can be accessed by D, even if it's in the different folders. But also V1 is also accessible by B and D, because it's a public. Everyone can access A, V1. So V2, which is part of A class, now is defined as a protected. Protected give you access only for the subclass, and you can see the dangerous of having a class B on the same folder of A, because B can access also what? V2. You thought that you defined this V2 as a protected, only will be accessible by the subclass. But unfortunately, B live on the same folders, has no relation with A, can access V2. Also look at the V3. You define V3 without providing any access modifiers, which let you access V3 from A, C, D. Sorry, D will not be able to access the V3, okay? But V3 can be from P, you can access V3. So why? Because when you're not defining any access modifier, you will have the package access. Even D is inherited from A, it cannot access V3, because V3 has a default access, which is the package access. That means C can access V3, D can access V3, but D cannot access the V3, because they live in different package. Okay? They are in different folder. When we say they are in the same package, that means they are same folders. Okay? That means B, A, and C, they are on the same folder, D in different folder, and E in different. So, but E cannot access V3. Now look at the private. When we have V4 as a private inside A, we cannot access it directly even from C or D or P or E. Private only accessible by the client itself, or if the client provide us with any public get method or set method to be accessed. No, not like the password in the employee, change the password. Okay? I recommend all of you after this lecture to look at this figure and make sure you understand it, because access modifier is play a very important role in the inheritance. Okay, there's some important this is most of the time programmer forget about it, which is the default package access I discussed with you. Even you see in the previous slide, we have V2 defined as a protected inside A, but B can access V2 because B live on the same folder. Okay, that is very dangerous for some applications. Okay, imagine you define credit card expiry date or a code for a credit card as a protected, and you have some package that live on the side the same folder. That means this package can access this protected field. So package default access is very dangerous. We have to be aware of it, and my recommendation to you from best practice, don't define anything as package access. Always put everything inside the package and make sure you have access valid access modifiers on the front of it. Okay, So all the instance variable and the method has access, package access. That means is accessible by any class that has also default access. And the dangerous thing here, whenever you create all the Java classes that don't have any package, all the Java will put them in this one class, one folders, which is default access. This is also another important we discussed related to that diagram. If you have a class P, derive class A, and inside class A you have a protected variable N, but a class A and P are in different packages, okay, which is similar to what to A and D in this diagram, okay. So in this case, the method inside a class A can access N by the name because N is inherited from A, and the class P can create a local object by itself by creating an object of type class P, and also still can access N because P inherited from A. This is a dangerous thing. If the method inside a class P create an object of A, okay, and try to access N, it will not allow it to access N because N is defined as a protected, and Java knows what is inherited, what is not inherited, okay, which is similar to the example we discussed about customers and employee, okay, customer and employee. Customer is trying to access an employee object protected, that is actually is not, there is no relation between employee and the customers, okay. Good. This is an abstract class. We will stop for this today, but I will talk to you a few things before you leave.